Hello everyone, very good day to all of you. You all are watching Insights, and today I'm going to teach you how we can solve algebraic fraction. Now, a normal fraction is something like this, 3 over 4, where 3 is our numerator and 4 is our denominator. If I introduce an unknown variable to 3, that is 3 plus 6 divided by 4 plus 3y, 3 over 4, which was our initial fraction, became an algebraic fraction. Now note that rules for determining the sign, that is whether this fraction is positive or negative, are same for the algebraic fractions also. Rules regarding general arithmetic principles will still the same for both type of fractions. Let's look at a concept related to cancelling of common factors. Now when we consider this fraction 3 over 12, we know that this is equal to 1 over 4 multiplied by 3 over 3. Therefore, our answer is 1 over 4. Similarly, if you take 3 over 15, both the numerator and the denominator can be divided by 3, leaving us 1 over 5, which is the most simplest form of this fraction. So the learning point is, we need to cancel common factors and express the fraction in its most simplest form. But however, when it comes to algebraic fractions, we might have to use factorization to express an algebraic fraction in its most simplified form. Now consider this example: x plus 4 divided by x minus 3 multiplied by x plus 4 is an algebraic fraction, where we can cancel the common term x plus 4 from both the numerator and the denominator. Therefore, we get 1 over x minus 3 as our most simplified version of this fraction. Let us now see how we can multiply algebraic fractions. Now, normal fractions such as 5 over 6, 5 multiplied by 1 over 4, what we do in terms of multiplication is 5 multiplied by 1, 6 multiplied by 4, which is 5 over 24. Similarly, for algebraic fractions such as 7 over 8x multiplied by 4 over 3y is equal to 28 over 24. 7 into 4 is 28, 8 into 3 is 24, x into y is xy. Consider this example: a divided by a plus b multiplied by b divided by 5a square. Now in this case, a and a can be cancelled off, leaving 1a under b. Therefore, our answer is b into 1 is b, 5a into a plus b. So the learning point is, multiplication rules that we applied for normal fractions are equally applicable for algebraic fractions. Now let's see how we can do the division with regards to algebraic fractions. First of all, let's recall how we divided normal fractions. Let's say 3 over 4 divided by 6 over 10. Now what we did was 3 over 4 multiplied by the reciprocal of the second fraction. We multiplied the first fraction by the reciprocal of the second fraction. Thereafter we cancelled the common factors and arrived at the most simplified version of the fraction. Here also we can divide. If we divide 4 by 2 we get 2. If we divide 10 by 2 we get 5. So our answer is 5 over 4, which can be written as 1 over 4. Similarly, when dividing algebraic fractions, we can multiply the first fraction by the reciprocal of the second fraction. Before doing that, we'll see what is meant by the reciprocal. Now 1 over 2 multiplied by 2 is 1. So 2 is multiplied by its reciprocal is 1. 3 multiplied by its reciprocal is also 1. 3 into 1 over 3 is 1. Therefore, we can say reciprocal of 2 is 1 over 2 and reciprocal of 3 is 1 over 3. Now let's consider some examples. Look at this example. X over 5 can be multiplied by 5 over x, so that our answer is 1, because x and x will get cancelled off. 5 can be cancelled again, 5, so I left it 1. Therefore, I can say the reciprocal of x over 5 is 5 over x. Let's solve some examples and see how we can apply this concept in finding solutions for algebraic fractions. Now 3 over x divided by 4y over x. So simply what we have to do is 3 over x multiplied by x over 4y. Therefore we get 3 over 4y. Let us consider some other examples. A over b divided by ab over 4. Therefore I can say a over b multiplied by 4 over ab. A can be cancelled off with a. Therefore I am left with 4 over b square. However, when there are algebraic expressions in both the numerator and the denominator, there can be complex situations where we have to factorize the expression, so that common factors can be easily found and they can be cancelled before simplifying. Consider this example. 3x divided by x squared plus 2x. The whole fraction is divided by 5x over x squared minus 4. Therefore, we can write 3x cannot be factorized further, but x squared plus 2x can be factorized as x into x plus 2. We can take x out, therefore we are left with x plus 2. Now this factored fraction should be divided by 5x, cannot be factored any further, but x squared minus 4 can be factorized as x squared minus 2 squared, which represents difference of squares. So we write this as 3x divided by x into x plus 2 multiplied by x minus 2 into x plus 2 divided by 5x, because x squared minus 2 squared can be factorized as x minus 2 into x plus 2. X plus 2 will get cancelled off. X and x can be cancelled off. Therefore, we are left with 3 into x minus 2 divided by 5x. Let us consider some more examples. Okay, look at this sum. It has x squared plus 3x minus 10, that is quadratic expression. Therefore, we factorize 10. 10 is 5 into 2. Therefore, we can factorize this as squared plus 5x minus 2x minus 10 divided by x. Whole fraction is divided by x squared minus 5 squared minus 5x. Now we factorize x squared plus 5x. We separate x. We are left with 1x from x squared and plus 5. We take minus 2 out. That is, this term is divided by minus 2. Therefore, we get x plus 5. Because minus 10 divided by minus 2 is plus 5. Therefore, x into x plus 5 minus 2 into x plus 5 over x divided by x minus 5 into x plus 5. Because x squared minus 5 squared is x minus 5 into x plus 5 over, we take the x out and write x minus 5. We take the common term out, x plus 5 into x minus 2 divided by x multiplied by x into x minus 5 divided by x minus 5 into x plus 5. And we can cancel off x plus 5 and the x plus 5 on the denominator of the other fraction. X and x can be cancelled off. X minus 5 can be cancelled off against x minus 5. Therefore, we can write x minus 2 over 1 as our answer. Let us consider another example. Look at this example. X plus 1 divided by plus 2 multiplied by x squared plus 6x plus 8 over x squared 4x plus. Now, first of all, like I said earlier, we have to factorize both the numerator and the denominator of the second fraction. We know 8 can be factorized as 4 into 2. Therefore, we can write squared plus 4x plus 2x plus 8. And denominator also has a quadratic expression that can be written as 3 can be factorized as 3 into 1. Therefore, we can write x squared plus 3x plus 6 plus 3. X plus 1 divided by x plus 2 multiplied by, we take the x out and we are left with x plus 4. We take the plus 2 out. Therefore, we are left with x plus 4 divided by, we take x out, we are left with x plus 3, we take 1 out, therefore we are left with x plus 3. So the common terms are x plus 4 into x plus 2, x plus 3 into x plus 1. So this is what we get after we have factorized the second fraction, both the numerator and the denominator. Then what we can do is, then we can cancel off x plus 2 with x plus 2 because it's multiplication. Plus 1 can be cancelled off with x plus 1. So we are left with 1 into x plus 4 is x plus 4 over x plus 3. Now that was about multiplying algebraic fractions, which involves complex algebraic statements which can be factorized. Now we'll move on to addition and subtraction of algebraic fractions. Now how do we add numerical fractions? 4 over 5 plus 3 over 2. What we have to do is, we need to take the least common multiple of 5 and 2. In order to find the least common multiple, what we do is we divide by prime factors. 5 divided by 5 is 1. We are left with 2. 2 divided by 2 is 1. Therefore 5 into 2 is 10. So we get 10 as the common denominator. 10 divided by 5 is 2. 2 multiplied by 4 is 8. 10 divided by 2 is 5. 5 into 3 is 15. 15 plus 8 is 23. 23 over 10. That is 2, 3 over 10. Let's consider an algebraic fraction. Look at this example. 4 over x plus y minus 3 over y. Now the common denominators of these two factors are x plus y into y, because x plus y into y can be divided by x plus y, and x plus y into y can be divided by y. Therefore we get x plus y into y divided by x plus y is y, y into 4 is 4y, minus x plus y into y divided by y is x plus y into 3 is 3 into x plus y, which we can simplify further as 3x minus 3y over x plus y into y. Therefore we get 4y minus 3y is y minus 3x over x plus y into y. Now there are proper fractions and improper fractions. A proper fraction is where we have your numerator less than your denominator. That is to say, the highest power of the numerator is less than the highest power of the denominator. Now this is a proper fraction, because the highest power of the denominator is 3, but the highest power of the numerator is 1. An improper fraction is where we have the highest power of the numerator is greater than the highest power of the denominator. In this case, the highest power of the numerator is 2, but the highest power of the denominator is just 1. Therefore, this is an improper fraction. Same thing can be identified with regard to normal fractions. Alright, in this discussion, we discussed about addition, multiplication, subtraction and division of algebraic fractions. If you like the video, do subscribe our channel, leave your comment in the comment section below, hit the like button. Thank you for watching. Have a great day.